Hi guys, you are welcome to my next tutorial. Today we shall be looking at merge sort. So merge sort is one of the sorting algorithm, and we'll take a look at it with some examples. Let's say for example you have this array as our input and you're asked to sort this array in ascending order. So if we want to sort this array in ascending order, let's see how we can do that. Now we have 8, 7, 8, 3, 2, 9, 7, 1, 5, 4. So how does merge sort works on this? The principle of merge sort 832. The principle of merge sort is that 3297154 is that it takes the array and the input array, it divides it into two equal halves. So it divides it into two, so that is divided into two, or better still we can do it this way. So that is divided into two, the left part and the right part. Now it takes this one, this left part, it does the same thing on it again. It divides this one into two, so that is divided into two. Then it takes this one again and divides it into two. So now after it has divided it and we now have a single element, then it will call the function merge on each part of this. So this is the left part, this is the right array, this is the left array, this is the right array. Then it will call merge on this. So what does merge do? Merge on this, we check which it will do, it will arrange this part. Merge sort is working on the principle that a single element is sorted. 8 is sorted, 3 is sorted. So merge works on two sorted array. So what it does is that it takes two sorted array and returns them sorted. So what it does, it compares 8 with 3 and swaps if it is not in the right sorting. So because it's not in the right sorting, so it swaps them. So we now have 3, 8. So and this is completed. Now this is completed. Now it takes the other part and does the same thing. 2, 9. It splits it until we have a single element. Now we have a single element, each of them is sorted, then merge is called on these two arrays, then merge return is sorted output of these two. So these two will be compared and they will be returned sorted. So by the time these are merged, they become sorted. So this is also sorted. Now after that, recursively, this becomes the left part, this becomes the right part. So we can come in here instead of this one that we have here. So this becomes 3, 8. So we have, this is the left part and this is the right part. So this is sorted, this is also sorted. So these two arrays are also sent to merge operation and it returns them sorted by comparing them one after the other, which we're going to see in the merge procedure. So this merge operation will return 2, 3, 8, 9 as the output of sorting these two arrays. So these and these are combined together to give us this. So this left part is sorted. Then again, recursively, the merge sort will pick the second part of this array and divide it into 2. So that is divided into 2. Then to pick this one again and divide it into 2. Now once we have a single element is sorted, then it calls the merge operation on this, and merge operation will return the sorted of the output, which is 1 7. Now it comes to this place, we call the merge sort on this, then it divides it into 2. Then the merge operation is called on this and it returns the sorted of the 2. So this one becomes 4 5. Now this is sorted, this is sorted, so the merge operation is called on this and this, then it returns 1 4 5 7. So recursively, the merge operation takes this is sorted, then the merge operation works on these two to give us 1 2 3 4 5 7 8 9. That is how that works. So we're going to look at now how does the merge operation, how does it compare the two sorted parts. So let's quickly look at that. If we have 1 2 and we have the second part, we have 4 we have, let's say we have 1 4 here, and here we have, say, 2 6. So how does the merge operation work on this? The merge operation is going to take the first element here, which is 1, and compare it with the first element here, which is 2. So is 1, if we are doing ascending order, is 1 less than or equals to 2? Yes, because 1 is less than or equals to 2, this one remains. This one remains, the pointer will move to this place. Then it will compare, is 4 less than or equals to 2? No. So what happens is, the first time it compares 1, is it less than or equals to 2? Say yes. So it copies 1 into a new array. Then the pointer moves to this. Is 4, is it less than or equals to 2? No. So it copies 2 into the new array and the pointer moves to this place. Then it checks, is 4, is it less than or equals to 6? Then it copies the one that is left, which is 4, and there's nothing to compare again, then it just adds this one to it. That is the technique behind the whole merge operation, which we shall see in our implementation. So let's see that. This is our code written in Java. This is the msort. Now the msort, first of all, check if the input array, if it has a length that is greater than 1. Then it divides the length into 2, create a new array, which is the left and another for right. The left takes the size of middle and the right takes the remainder, which is length minus middle. Now we iterate through the array. To be able to copy the values in our array into the left part. We do the same for the right. We copy the values of the array from the middle to the end into the right part. Then we call m sort, which is match sort, on left and on right. And then we call match on our left and our right, as we explained earlier. And the result we put into a new array B. Then we iterate through the result of our match, because our match is going to return a result. We iterate through the result of our match and put that result back into A. So as our match is giving us result, we are loading it back into our A. And that's the end of the match sort. So let's see the match operation. The match operation takes two arrays, X and Y. We initialize I to track the X array, and J to track the Y array, and K for the new array C, which is going to be of size of the two arrays. Then as long as I, which is tracking the X array, is less than its size, and J is less than its size, we do our comparison. If the value of X of I is less than or equals to the value of Y of J, if it is, then we copy our X of I into X of K. Then we increment I and K. Else, we copy our Y of J into C of K. Then we increment J and K. And that's all. So once we are done with that, if there's any element that remain inside our X array, we just copy them sequentially into K. And if there's any element that remains in our Y array, we just copy them sequentially into our C. And that's all. And you can do a printout of what the C returns, the match returns. By the time the match is returning result, is returning a sorted array. And that's all. You can find the code on our GitHub page. And the time and space complexity is in big O of n log n, and the space complexity is in big O of n, because we have to create an entirely new array to be able to hold the result of our match operation like we did in this case. So, and at most is going to be the size of the initial array, which is n. So thanks for listening. If you don't mind, I can just do a quick demonstration of the code that we have in our GitHub page, so you can look at it. So this is the code we have on our GitHub page, and if you look through this, we have the main method, and these are some test instances. So for instance, if you want to send this as our input, you can just send this as our input into array. So this is our input array, then we print our input, then we call msort on that input array. So, and this is what we followed in the explanation, and this is the match part. So you can just see a quick demonstration of that. I say Java match sort, then Java match sort. So you see, this is our input array, and this is our sorted array. Thanks for listening, and see you in the next tutorial.